know how we can actually plot charts in Python. Uh, Lakshya, do we take a break for like 2-3 minutes, or do we just continue with this?
Manish, as you are comfortable.
Okay, all right. So I can probably continue and then finish it in another 20-25 minutes. So let's continue with this. All right. So first things first. I'm not really sure how many of you are actually having some hands-on or any working knowledge of Python. But for people who are not, what I will do is let you know how you can actually get started on Python really quickly without you requiring any installation or any setup, right? So there is a tool named Google Collaboratory, which is provided by Google, and that's what you can use to get started really quickly. So in in the browser, you can go if you have the only prerequisite is you need to have a Gmail ID, and that is it. Uh, so what you need to do is you need to go to this URL, collab.research.google.com, uh, and then just hit enter. So what Google guys have done is they have created an environment for you where you can actually write your Python code, and all of the code that you create, it can be easily linked with either GitHub if you have an account already, or you can actually save all of them in your Google Drive. So it has an integration with Google Drive, or you can actually keep these files locally as well. So you have all of these variety of choices. The good thing is you can just like I said, go to collab.research.google.com and just create a new notebook, and you are good to go. That is it. You do not need any local installation. You do not need anything. So I'll quickly let you know. Here you can actually name your file and just hit save. This is for now, like you see this icon saved in Google Drive. You can also save it locally. What you can do is you can write your Python code in here, and you can just execute this. It is as simple as that. So what Google does is it's a on-cloud solution. So it assigns you you know uh, a machine on the cloud where you can actually run all of your Python code, and you can just keep adding the lines of code uh, and keep running them. That is it. As simple as that. You add more lines of code, and you can actually keep doing that for whatever you want to do. This selects this actually supports multi-line as well. So do not think that you'll need to actually add new snippets of code in every add snippets of code for each line. That is not true. You can actually do multi-line as well. So this is how you actually get yourself set up. And why I'm telling you all of this is because you will need to, we will be sharing the Python notebook, which I've used uh, to showcase the charting options in Python so that you can actually run them for your practice as well. So first things first, I mean, how this idea of how this idea came into being, where we wanted to show you how to chart in Python. So the idea was very simple, and it was definitely not to do any kind of a comparison between the capabilities that W exhibits versus the capabilities that Python exhibit. That was definitely not the idea. Uh, as people, as professionals who belong to the data space, we should be uh, aware of what other tools, what other technologies are available, which lets you do similar stuff. And Python has a very good, very rich library in terms of Matplotlib and Seaborn. Uh, which lets you chart really quickly. Uh, I'm not promoting that you should be using Python in this case and not Tableau at all. That's not what the message is. What I'm saying is once you know, then you know which is easier for your specific needs, right? If you were to do exploratory data analysis and that's something which you need to do or maybe want to automate, Python would be one way of doing that. If you really want to do it in Tableau, then all of these needs to be like rebuilt based on how the data set is, and you cannot really automate it there. So that's one flip side. But then there are specific things which Tableau does really beautifully, and then there are specific things which Tableau does beautifully. And once we know both of them, I think what happens is we empower ourselves more as professionals, and that is the whole idea of me doing this session today. So let me get started with this. What we are doing here is importing a few libraries in here. If this is your first session where we are, you're getting a hands-on on Python, then a lot of these may not make sense to you. But then if you have ever programmed in any language, let's say Java, in your academics or what, then you know that the first things that we need to do in programming language is import the libraries that we want to use. So the two libraries that we are going to use today is Matplotlib. This is a standard library which comes uh, in every package of or every version of Python. And the other one, which is a slightly enriched one, is Seaborn. That's something which comes bundled with some of the Python versions. In others, you need to actually install it separately. And what we are doing is importing both of these libraries. Uh, in addition to this, we are also importing pandas. Pandas is a standard library that lets you manipulate with data tables, which we call as data frames in Python. So how can I execute this line of code? There are two ways. You can either click on this run cell using your mouse, or you can just do control enter, and it'll just execute the code. I have already executed this piece of code, so I'm just skipping this for now. What it is doing is it is mounting my Google Drive uh, so that I can read a data file which is saved in my Google Drive. I'm not doing this here in this session with because of the reason that it redirects me to my Google account, generates authorization code, which I'll need to copy and put it here for this line to finish. I've already done that, so that is not a requirement. The other thing is all of these are getting recorded, so I definitely not want my authorization code to be exposed on a public forum. So when you do this, the only thing that you need to do is when you run this line of command, after running, you need to click on this link, go there, generate the authorization code, and then enter in a little text box which will appear here, and you'll get this message mounted at content drive. So what I'm trying to do is I have a file named churnmodeling.csv, which is saved in my Google Drive. And I'm just trying to read that CSV file. The command is very simple, read underscore CSV. And this is available in the pandas library. So what I'll do is execute this line of code now. And that's it. It did not give me any error, which means it succeeded. The next one that I'm going to do is inspect this file and try to figure out what are the contents of the file, right? So the command for that is dot head. Uh, Data is my data frame. So data dot head 10 would give me the top 10 records from the file that uh, read through using this function read underscore CSV. So if you now look at this data set, it has data from a hypothetical bank, right? The customers of a hypothetical bank, rather. So what it shows you is customer ID for these customers. So one row of record is representing data for one customer. So we have customer ID, the surname for that customer, the credit score for that customer, the geography that customer belongs to, the gender, age, Tenure is the total number of years the customer has been a customer to the bank. The balance maintained by the current balance maintained by the customer. Number of products that the customer has. So it may be the case that the customer only has a savings account, but then another customer may have a loan as well as a credit card on top of the savings account, right? So the total number of products that customer has uh, is using from the bank. Does have a credit card or not, one or zero. These are flags. Is an active member based on recent transactions. Estimated salary, really don't know how a bank would know unless you hold a salary account with the bank where they can actually know how much of a salary you're getting every month. But they have a field, and then exited is an interesting field, right? Which what it means is, uh, did the customer actually continue with the bank, or they close the account and move to some other bank? So the first 10 rows of this record is what we have here. The reason I spoke in length about what this data is, because if we do not understand how the data is structured and what one row of data would mean, there is no way we can do any further analysis or understand any analysis going forward. So let's move forward and try and show what we can do with the libraries that we have in Python to chart some of these, right? So the very basic one, which we have in Tableau as well, is a bar chart, right? And what we have done here is, if you look up, we have named the Seaborn library an alias name as SNS. So what we are doing here is sns.barplot. So what it will do is it will create a bar chart. On the x-axis, it's going to put the gender field. Y-axis, it's going to put the balance field. So we have, if you look at it here, gender, female and male, and then we have balances in here, right? These are going to be dollar amounts. So what we are trying to do here is, and then data is equal to data. This is a parameter where we need to specify which data frame you want to use, from where you want to get the x and y values for gender and balance, right? So since when we read the file, we assigned this into the data frame named data. This is what we are specifying here. So what this is going to do is, primarily, this is going to show me, if you could guess it correctly, who or which gender has a bigger uh, balance in terms of dollar amount, male or female. So let's just plot it out and see as to what the chart shows us. So like you said, male appears to have slightly bigger bar compared to female. What it means is really simple for us to interpret, right? So I'm not going to go into that. If you look at it, it has already assigned a color, which we never specified. We can change the color as well by specifying a few parameters, which you can look at by just clicking on, uh, clicking inside the function and uh, pressing a comma. So you can specify these colors. By default, the color option says color is equal to none. So it just picks a color of its own, which is fine for now. We do not have a lot of bars in here, so we do not want to actually specify this parameter in here. So simple. Some of in if we were to interpret as to how we would do this in Tableau, then we would need to put gender into the column shelf, and then sum of balances into rows, and convert the chart type to a bar, and that is what it would represent there as well. Moving on, trying to get into a few more examples for bar plot. So what I'm now trying to do is, I'm just trying to figure out which geography has more balances rather than gender. So on x-axis, we have specified geography. Y, we still hold balances there. So let's see what happens. So now there is a marked difference, right? Germans seems to be having more bank balances with this bank, the hypothetical bank that we were looking at, and Spain and France seems to be pretty much head to head in terms of balances. Yeah. Uh, Moving on. There is a slight variation to this chart, right? If you look at these parameters, I mean, this is still a bar chart, but then if you look at these parameters in here, on the x-axis, we again have geography, y-axis, we still have the balance. So far, it is the same as the bar on the top. But if you look at the last parameter, hue is equal to gender, then what we are trying to do is we are trying to break this chart further on gender. So we want to know for all of these geographies how the different genders have been maintaining their balances. So what it means is, if you were to try and recall what happens in Tableau when you put your gender in color, then it separates the bar into two colors, each one for each gender. Uh, and that is what is happening right now. Uh, it broke down the geography into genders, and this is how it is. I mean, gender-wise, still the same trend, because that's a worldwide trend based on the first chart that we built, right? Pretty much head-to-head, male seems to be having slightly more balances than female, but very, very minuscule. And then the same trend is observed here as well. So what we are doing here is we are actually using this fourth parameter hue, which is equal to the field name, to actually break this down further. You can think of this as a stack bar chart. It's just that the bars are the male and female components of for any geography. They are not showing on top of each other rather than on side of each other. So in Tableau, if you would have done this, then you would have probably put two fields in column. One is geography, and then the other one is gender. On the row shelf, you'd have sum of balances. So pretty simple, pretty easy commands. Now let's look into some other chart types. The first one is scatter plot. So what we're trying to do is we're just trying to figure out, do people tend to have more balances as they age, or or what is the trend, right? Do younger people have more tendencies to have more balances, or do elder people have tendencies to have more balances, right? If that's the kind of analysis we want to do, what we need to do is put them on a scatter plot. So our x-axis is age here, and y-axis is going to be balance, and let's see what it does. So this is what it is. It shows you a scatter plot. Like I said, on the x-axis there is age, y-axis we have balances. But if you really want to try and figure out if there is a trend, uh, um, you know, we all are going to struggle, because looks like there is no trend as such. If you look at these lower age numbers and move up on the y-axis, you'll see you will have smaller values for balance, as well as bigger values for balance as well. Same ways, if you look slightly up on the age scale, which is around 70, you also have smaller values for balance as well as bigger values for balance, right? So there is no trend as such. So what we can do is we can further break this down into maybe gender by including this field here, hue is equal to gender, and see if there's a pattern uh, that we can identify. And let's do that. Um, and what it has essentially done now is, if you look at these two charts, it is kind of the same as you putting gender on the color shelf, and color marks card rather, and trying to figure out if there is a pattern between male and female uh, bank balances based on their age. And again, if you look at it right now, it's pretty much looks like these are all pretty well mixed up, all of these colors, we really do not have any pattern that we can actually identify across the age scale on the x-axis. So, which may mean that all the age groups are actually saving similar amounts of money and having them in their bank in their banks as outstanding balances. So that is what we can do with scatterplot. If you look at the function itself, these are pretty self-explanatory. For bar plot, we had bar plot. For scatterplot, we have scatterplot. So moving on to the next one, we have a LM plot, right? It means line plot, but then this chart is pretty interesting because it lets you do a few fancy stuff without you having to write much code. So what I'm trying to do here is, and this is going to be almost the same as a scatter plot, let me tell you that, right? So what I'm trying to do is, again, I'm taking the same fields like it took earlier, age and balance. So on the x-axis, I have age, and on the y-axis, I have balance, right? Uh, and then I have hue as gender as well. But then there is this additional field, option or parameter rather that I have uh, set as false, and that's something which is I'm going to explain you now. So if you look at this chart, let me just remove this. This is going to be not much different than the chart on the top. Uh, and you will not be able to identify much patterns in here. So what I've tried to do is I have tried to limit the data to just top 50 rows and limit the data so that we can actually make sense of uh, the dots in some manner. And what I've done is I've only selected the top 50 rows by putting in data dot head 50, similar command that we used earlier to show the top 10 records. So now what it is trying to do is again show me for the top 50, the first 50 rather, the first 50 records, how are their balances placed, right? But then it still looks like uh, scatter plot, like a simple scatter plot, and does not let me figure out the pattern myself. Uh, but if you actually uh, change this parameter value, which is fit underscore reg is equal to false to fit underscore reg is equal to true, then this is where this gets interesting. If you look at the dots on the chart, this is going to be pretty much the same as how it is on the chart on top. But then we have some shaded areas, blue and shades of orange. And then we have lines cutting through these shaded areas. Now, what are these? If you've heard of this word or this term named regression, which is one of the very basic machine learning principles or tools that we do to estimate numbers, then this line actually represents the equation to that model. If I were to simply explain you as to how to interpret this, what it means is uh, this is the best fit line. This is the best fit regression line, which represents the change in the data, right? So how is my data changing? On the x-axis, my age is increasing, and on the y-axis, if we go up, my balances are increasing, right? So if you look at this orange line, what it suggests is it's for male, right? So what it suggests is as the age is increasing, male have a tendency of having more balances. Uh, on the flip side, if you look at this line on the blue line, as the age is increasing, there's a decrease in the balances. Although the slope of the line is not very steep, so there's a decrease, but not by much. If you look at the slope of the orange line, then it is slightly more steeper on the opposite direction than the line, the blue line, right? So uh, basically, you can do quick regression analysis as well using this parameter and then the LM plot. The full name is line plot, and you can use this parameter to do quick regression analysis. Um, there is also another chart type to do regression plot, and that's something that you can do as well. Let me show you how to make this work. Yeah. So if you look at this chart here, and then the chart on the top, uh, there is no much difference except for the fact that on the top chart we have used hue. So we have gender demarcated, as well as when you look at the regression plot, it has two lines, one for each gender. That's something which is how uh, which is distinct between these two charts. But let's say if I remove this option of hue here in the LM plot, then what happens? I'm assuming that both of these charts will be almost the same, and this is what is happening. If you look at the chart on the top and then the chart on the bottom, they are exactly the same, showing you regression plot for the first 100 records. But then the beauty of LM plot is where you can actually add in this extra parameter for hue and actually make it more informative, as well as make it look much nicer as well. So you can do quick regression analysis here using LM plot. Uh, and that is one of the reasons probably LM plot is preferred more than regplot, which is also used for regression. So moving on, there is one chart type which is very interesting. Now this is something which is supported in Seaborn only. This is not available anywhere else. Like this chart type is not available anywhere else in any of these other libraries. So, uh, wow, pretty interesting, right? What I am trying to do on the x-axis, if you see, I'm trying to do a violin plot, and on the x-axis, I have gender. So I have two violin looking like charts, one for female, one for male. And on the y-axis, we have balances, right? So we are pretty much using the same fields, and our data frame is named data. So data is equal to data, right? If you look at this chart type, I mean, it is a mix of two charts actually. If you have used a box plot, then if you look at uh, what is appearing inside the violin is a box plot only. It's nothing else, nothing other than a box plot. So this black bar, this shows the IQR, the 25, the second quartile, and then the third quartile. This little dot here is the median number, and then this is max, and then somewhere down below you'll have min as well. And the same is being plotted for the other category as well. So inside what you see, inside of violin, what you see is a box plot. But then what are these contours, right? Now these contours are nothing, but if you look at this very closely, uh, this is a histogram, but then this is not facing upwards. This is facing towards the right and towards the left. And if you look at both of these sides, they are like mirror images of each other. So what essentially it means is if I were to put in my mouse here, then it means that whatever the magnitude of this line is from this black bar here till here is the number of people who are maintaining a balance of 100,000. That's it. Uh, and if you were to quickly interpret a few things, what it also suggests is that most of the people are having a balances of around 125K, because because this this contour is steepest at this point at around 125K. And since we have already seen that there is no much on a holistic view, there is no much difference between the balances of male and female. Both of these violins appear pretty much the same for us. So there's no fun in looking at these, right? So what we can do is try to find out if violins could be different for another category, and that's what I try to do here when I was looking at geography as well as balance and figure out what's the violin plot pattern there. So if you look at France and Spain, their violins look almost the same. But if you look at Germany, then you have a different shape altogether. Now let me go back and actually show you why it's like this, right? We've already seen some similar pattern earlier as well, right? Germans had a tendency of having more bank balances in this bank, hypothetically, and France and Spain had almost similar balances on a net basis for the country. And this is what is showing up here as well. If you look at uh, you know the wing, if I may say so, of the violin for France and Spain, there are a lot of customers who are having balances of 0, and that is why it has a a wing, or a fin rather, uh, towards its tail. But then there is no such structure in here, which means uh, Germans do not have uh, a 0 balances. The minimum balances that they have is around 15,000 K uh, in this bank. And if you look at here, what appears to be the case is uh, that almost all of these three regions have the same amount of you know uh, so maximum people from all of these regions have balances in the range of 125K, because this violin plot is the widest at this location. If you project it on the scale, it will turn out to be 125K. Same is true for Germany as well. All right. Talking about histogram, right? So, what a violin plot is, in a sense, it's a mix of two charts. The inside of it is a box plot, then the outside of it is histogram, um, turned by 90 degrees, facing on the right side and the left side, and both of these sides are mirror images of each other. Talking about histograms, how do we draw histograms all by ourselves? This is going to be very simple. The command or the function for that is distribution plot. They call it distribution plot in Seaborn. So you can just specify a field, and then you can get started with this. Now this chart is something which looks really beautiful, because not just it shows you the bins, the auto calculated bins, but then it also shows you a smoothened line which shows you the skewness in the data. So if you look at this, you can really maybe not looking at the bars, but then looking at the line, the smoothened line, you can definitely conclude that it has some kind of right skewness on age, which means more younger people are, more number of people who are customers to this bank are younger than the older generation. So yeah, so this is what gets really visible when you look at this distribution plot. We can also look at this distribution plot with some other data items. The next one that I try to do is balances, and let's see what happens. And this is very interesting, right? Uh, Not something that we have not seen earlier. We have already identified these patterns in our other plots as well, right? So what it suggests is the majority of the people are having uh, 0 balances in this bank. Now, are there other charts which hinted us at this? Let's figure out. If you look at these fins, these are broader. These are broadest actually, even broader than what we have here, right? Uh, Here, right? Which means there are more number of people having 0 bank balances for this geography, Spain and France, than people having 125K. balances. And did you notice it here as well in the scatter plot? There are a lot of uh, zeros on the y scale, even on this x-axis where we have age increasing, right? These are all suggesting that all of these are zero bank balances for many people, and these are just top 100 records, right? We are just doing this for top 100, the first 100 records, right? And we still have a lot of zero bank balances in there. This is what the histogram is suggesting here as well. Lots of zeros, and if you just leave this part or ignore this part, then the rest of the curve is pretty much like a bell curve, like a normal distribution. So we can identify these, patterns really quickly. Let's quickly look at what happens to our credit score histogram, right? So that's what I've tried to do here. When you look at the histogram for credit score, this is also pretty much a normal distribution, like a bell curve. One thing which is to note here is, and this is something which is like a standard concept. Wherever you see steep lines, either to the left side or to the right side, you know, a bell should ring in your head that something is wrong. Uh, Either that the nature of the data is such that there is a pattern that you need to take a note of, or maybe there are some unit issues, currency issues, or issues in capturing the data. So what is likely to happen here in this case is there are a lot of people who are having a credit score of this maximum value. I can't really figure out what this maximum value is, but then I'm assuming this to be 850. But if you explore more, what is actually true is you cannot have a credit score of more than 850, which means if you have a credit score of more than 850, then it is capped at 850. And that is what explains um, the length of this bar. So now that we know of what is the maximum value, chances are that if that was not the case, then it would have been broken down into smaller bars, leading to 900,000 hypothetically, maybe 1200. I really don't know. But then all of these are kind of getting accumulated in 850, and that is why the length of this bar is so high. So that is with distribution plot. One other thing that you can do with distribution plot is really make it look like a step, and I'll explain that to you in a while. First, show you how it appears. So instead of showing the bars of the bin as bars, what we can show is only show the outlines of them. So that it appears as step. And if you can look at it, what is not appearing here is the bar itself, just the outlines of the bar, the top outlines of the bar. How do we do this? We need to add as additional parameter hist kws, and here we need to specify hist type or histogram type as step. We need to specify the line width. So if you change this, then the lines will be much thicker. A 5 will be even thicker than a 3. And alpha is equal to 1. It's a parameter to control uh, the intensity of the color. So how faded or how dark the color would appear. So, I mean, you can play around with these settings. These are not really difficult to deal with. The only thing which is important here is if you really want your histogram to appear as a step chart, then you can add this parameter his type is equal to step in here, and that is what it is. Uh, okay, all right. So we're pretty much towards the end of it. Two more chart types remaining. I hope you guys have been enjoying the session so far and learning a lot. The next one is I'll show you we call it a heat map, right? And this is something which people who have already worked on Tableau would know what a heat map is, right? So I'll first show you how it appears, and then I'll explain you as to what the command looks like. So what I've tried to do is show a heat map between balance and now I've picked a new field, which is tenure. So tenure is the number of years a customer has been with the bank, and balance is their current bank balance. So what it shows, what I'm trying to show is there a relationship between tenure and balance, right? Are people who are uh, having are people who are with the bank for longer duration, do they have the tendency of saving more or having more balances, or what is the trend there? So uh, the function that we have to use here is, of course, sns.heatmap. That is pretty explanatory, and we need to specify what is the data that we want to plot, and then we can specify uh, color map, RDBU. It sounds very complicated, but then this is short form for red and blue, RD red, BU blue, and you can change your parameters. So it is changing between shades of red and blue. If you look at the scale on the right, uh, right, so red is 0, and then the minimum value is red, and then the maximum value is shade of blue, and then the colors are changing based on the magnitude of the values. We can change this to whatever set of two colors. What is important to note here is we need to actually transform the data using this pivot table uh, function to be able to do this. And this is a prerequisite, right? And this is where we actually specify all of these parameters. So if you look at heat map function, we have not specified which column you want or which field you want on the x-axis, which field you want on the y-axis. That's not something which is happening here, which is pretty contrasting to the other chart types where we specifically specify uh, our two fields, right? So distribution plot is one field, but when you look at violin plot, we specify what goes in the x-axis, what goes into the y-axis. Same goes for LM chart as well. We specify what goes into the x-axis, what goes into the y-axis. But in case of the heat map, what you see is we do not have these parameters specified here. Instead, we are just passing a data frame, a pandas data frame, and this is being created using a pivot table function, where we are taking the first 100 records from the data set and specifying the values to be balance and index to be tenure. So index is nothing but the x-axis, values is what appears on the, no, wait, values is what appears as the colors, and columns is what appears in the x-axis. So columns is x-axis, uh, tenure, which is index, is nothing but the y-axis, and balance, which is values, is the magnitude, the relative magnitude of these boxes in terms of colors. So that is how you actually plot a heat map. This is slightly a 2 or a 3-step process rather than a 1-step process for the other chart types. So this is additional step. You need to actually create a pivot table using these parameters. One thing that you can actually also do is you can actually increase or decrease the uh, size of the chart to your liking. So what I've done is done a 30 uh, width and 3 units of height. What you can also do is you can do 20 and 5. So I'm reducing the width and increasing the length, and you can suit yourself based on what fits your need. You can also save the image by just right clicking on it and saving it to your file location. This is as simple. Um, this is something which is true for any chart, by the way. You can just right click and then save. The last one, and this is a very interesting one, is a variant of scatter plot, but then it lets you do multiple scatter plots at once. And the name of the plot or the function itself is PairPlot. So what it does is it takes multiple fields as input. So what I've done is credit score, tenure, and balances. These are the fields that I've specified. And what the PairPlot is going to do is it is going to actually show you the relationship between all of these three fields with each other, taken two at a time. So how does credit score look like when uh, when what is the relationship between credit score and tenure, then what is the relationship between credit score and balance, then tenure and balance, and likewise. So let me just plot it, and it will become clear to you. You can specify, you can even increase it to 10 number of fields, right? So if you look at the chart below, uh, you have a credit score in the first row and credit score in the first column. So if you look at this chart, this is credit score versus credit score. So, if you move diagonally, all of these are going to be so the same fields, right? So tenure versus tenure and balances versus balances. So always in a pair plot, if you look at it, diagonally going down from top left, you will always have a histogram because you cannot plot a scatter plot using two fields which are same. When you do that, then you will have you cannot really plot it, right? You'll have overlapping dots maybe. So it will not make any sense. So what W does is in a pair plot, diagonally from top left to top right, it plots a histogram. But the interesting part is where the scatter plots are plotted right now. So when you look at this first row and second column, what is being plotted here is credit score versus tenure. So how does my credit score versus tenure scatter plot look like? This is an answer to that. And then the third one, third column, in the third column, we have credit score plotted against balances. So how PairPlot is beneficial for us is we can actually create multiple scatter plots, and we can do a n cross n type of a comparison using a PairPlot. If you have multiple factors or multiple fields and you really do not know how they correlate to each other, and you really need to do a brute force analysis where you need to compare each field with each other field in the data table, then what you really need is a pair plot and not commands like these where you actually plot one uh, scatter plot each at a time. So if you do these, then primarily you'll need to do all of these permutations and combinations across all of these fields together for yourself, and then you will also need to write all of these commands yourself, that too manually, one at a time each. So that's not something which is required in this case. What we can do is we can quickly do a brute force scatter plot. That's the way how I like to term it, but then the name of the function is pair plot. There is some duplication in here. I'm not sure if you already noticed, but then if you look at this chart, this is credit score versus tenure. And if you look at this chart, this is tenure against credit score. So it's essentially, if you look at this chart and this chart, they should be the same. And they are actually the same. It's just that their axes are flipped. So if you take this chart and rotate it anti-clockwise, I'm just repeating, if you take this chart and rotate it anti-clockwise by 90 degrees, you should be able to envision this chart. I'm not sure if you're able to do that mentally right now, but then that is what it is. If you rotate this, flip it by 90 degrees, uh, anti-clockwise, you get this. Same ways, this chart, tenure versus balance, would be the same as balance versus tenure. And again, the same story. If you flip this one uh, or rotate this one 90 degrees anti-clockwise, you get this chart type. So, and with that, I'm pretty much done with what I needed to cover for today. I really enjoyed taking you guys through this session, which almost lasted like 90 minutes. So thank you for paying attention. What we will now do is move to maybe take a little break and then move to the next session. I'm going to hand it over to Lakshya now. And in the meantime, I'll look at some of these questions that you guys may have raised. If there are any unanswered ones, I will probably